In this question, you're given a particular series, which is 1, 3, 5, 7, 9, and it just adds 2 each time to get the next number. And then the question is, how many terms will be required to get a sum just over 100? What if I had to ask how many terms are required to get a sum just over 10? So if I've got 1 plus 3, that gives me 4, that's not over 10. So let's add the next one. 4 plus 5 gives me 9, still not greater than 10. 9 plus, so my series was 1, 3, 5, so the next one is 7. 9 plus 7 gives me 16. So now I am above 10. So how many terms did I use? I used 1, 2, 3, 4 terms. So that's what the question is asking. How many terms do you need? But this time you want to get a sum just over 100. So in trying to solve this, the first thing you should be aware of is you want to generate the terms. So I want to get the terms. And if I start off at 1, I just need to accumulate by 2 each time, and that's going to give me the terms. But in solving this, each time I also want to calculate the sum. So as I work out the term, I'm calculating the sum each time of the terms. And then they want to know how many terms are required to give you a sum just over 100, which means I also need to count. So there are 3 important things that are required in solving this. Generate the sequence of terms, sum them up, and then count them up. And you want to know when your sum is just over 100. So your condition, remember this is going to entail using a loop. Your condition is going to be dependent on the sum. When the sum is just over 100, you want to stop. How do we go about solving a question like this? Right? So here we're going to say, let's create a variable called term, and let's set term to 1, because that's the starting point for the term, which is 1. I need to sum them up. So let me create a variable that's going to accumulate the terms, and let me set my sum to 0. And I need a counter as well. So let me set up my count, which is going to be set to 0. So these are the 3 variables that I need. So let's bring in my loop now. Remember, we said the loop was dependent on the sum. So while the sum is less than 100, I want it to loop. So while it is less than 100, you continue looping. The minute it goes greater than 100, it's going to stop the loop, and that's what we want. The minute it gets just over 100, the looping will then stop. So while the sum is less than 100, get the next term. Let's get the next term. So the term would be term plus 2, because that's how the terms are changing. So it starts off at 1. 1 plus 2 will give you 3. 3 plus 2 gives you 5, etc. So that generates the term. Once I've got the term, now let's accumulate the term. Let's sum that up. So sum equals sum plus the term. I generated the term, and now I'm taking the term and I'm accumulating it. Remember that sum started off at 0. And remember, we also need to count how many terms are required. So let's create my counter, which was 0. Count equals count plus 1. And then we're going to go and we're going to say end. So what's happening here? While the sum is less than 100, so sum is 0, Term is 1, count is 0. Sum is 0. Is that less than 100? True. So term equals term plus 2. So the term was 1. 1 plus 2 is going to give me 3. So the term is now going to be 3. Sum is sum, which is currently 0. 0 plus the term, which is 3. 0 plus 3 is going to give me 3. And count equals count plus 1. Count was 0, and 0 plus 1 equals 1. I'm not sure if you all picked up the mistake. You would have heard me hesitate because I picked up a mistake in the coding as I'm tracing. I'm hoping that you all picked it up as well. Now, notice that term is starting off at 1. That is my first term. I've already got the first term. So if that is my first term, then my count should also start off at 1, because that is my first term that I already have. And my sum should also start off at 1, because that forms the first term that I'm building into my sum. So when I get into the loop, term, I'm generating the next term, which is 1 plus 2. So that's correct, 3. But sum now is equal to sum, which is 1 plus the term 3. So 1 plus 3, that's giving me 4. So that's now better. 1 plus 3, there it is here, giving me the value of 4. And count equals count, which is 1 plus 1, giving me a value of 2. Because now that is my second term that I just added. So that looks better. So I go back up. What's my sum? The sum was 4. Is 4 less than 100? True. We come inside. Term equals term. Term was 3. 3 plus 2 now gives you 5. Sum equals sum, which was 4. 4 plus 5 giving you 9. Count equals count plus 1. 2 plus 1 gives you 3. And this loop is just going to continue in this way. And you'll notice the sum is incrementing, and eventually at some point, the sum will get just greater than 100. And once the sum gets greater than 100, then the loop stops and we go into output. Let's use a show message. And in my show message, I'm going to say number of terms. And I'm going to print count, which tells me the number of terms, which is going to be into string count. There we are. So this is the code that's going to be required to solve a problem like this. Now, you will remember that with a while loop, we want to ensure that the while loop satisfies ITC, initialize, test, and change. So let's look to see whether this while loop is satisfying ITC, initialize, test, and change. Always look at the test first. So what am I testing? I'm testing the sum. So is the sum being initialized? There it is. So that is your I. I'm initializing the sum. This is your T. That's your test. And then the C is the change. Where am I changing the sum? And that is where I'm changing the sum. So I'm using a while loop. And whenever you use a while loop, always make sure you achieve the 3 I, T, and C. If you don't have that, that means if you leave out the initialize, what are you testing? And if you don't change the sum, then it means that you're testing the same value each time the loop executes. And that's going to get you into an infinite loop. So just be careful when you are solving problems of this nature.